Hi friends, my name is Joaquin Herreros and I am the founder of Synchronize, a tiny renewables firm that was born with one purpose: make floating photovoltaics cheaper than installing it on land. Now the natural question is, but why? Please let me explain it. Regardless of whether you think it's something natural or man-made, climate change is a fact. Here in Chile, we have had 11 consecutive dry years, all below the average of the previous 50 years on record, and we are already seeing our lagoon disappear. As can you imagine, our farmers are having a hard time. Rising production costs and the climate-related risk are suffocating their finances, and even with the massification of driven irrigation systems fed by small reservoirs like this one, due to water shortage, they are portrayed as the bad guys, forgetting that they grow the food we eat, creating jobs, and being the front line in the fight against desertification to keep our lands green. Foreseeing that if this trend continues, local glaciers will disappear in the next decades, glaciers that supply us with water in summer, here important people even talk about creating artificial rivers or making desalination plants to service 6 million people, transporting water from at least 85 kilometers away. All this when big reservoirs are not even considered as projects, as nobody wants their backyards underwater. So it can be said that things are getting pretty bad and all alternatives should be considered. This is where floating photovoltaics make their entrance. Current technologies to cover surface water against evaporation losses are quite effective, about 80% of evaporation avoided, but they are also expensive, costing more than $500,000 to cover 1 hectare. But floating photovoltaic plants reduce evaporation as a favor since their electricity productions help to discount their investment cost. As example, here in central Chile we lose about 75 centimeters of water by evaporation during a year. If we can save, as a conservative estimate, a third of that, consider that cherry plantations use about 8,000 cubic meters of water per hectare in a year, we could save the same amount by covering 3.5 hectares. With this ratio, you can see the evaporation losses are not negligible at all. Being already widely known the benefits for installing photovoltaics, as well as knowing the synergies of installing them on water such as lower temperatures that increase electricity production, as well as the availability of water for cleaning the panels, the diffusion of floating photovoltaics has been quite slow here, with only a few projects built so far. Farmers even have economic benefit from installing photovoltaics, as they considerably improve their qualifications when applying for grants for the installation of modern irrigation systems, but they must sacrifice productive land that is much more profitable with discouraged spread of photovoltaic installations in agriculture. So in principle, floating photovoltaic on small reservoirs is a perfect fit, as farmers can both enjoy lower electricity costs and take advantage of the terrain offered by the reservoir surface. What's more, those aforementioned 25 centimeters of water rescued from evaporation could become very valuable thinking about an extra irrigation to protect against frosty mornings during the flowering season, which a few years ago were unusual but which have become increasingly common due to climate change, and which are very detrimental to fruit production yields. And with all these benefits said, one seriously thinks how floating photovoltaic has not spread like wildfire. Well, the main reason is what I have heard from my potential customers, is that since the required investment is higher than installing it on land, and its differential benefits are not directly reflected on the production bills, it is difficult for managers to defend these projects with the owners of those farms. But how to make it cheaper, or more importantly, how does a random electrical engineer like me do anything about it? Surely the companies that already installed them have teams of academics asking the same question. If I want to get an advantage, I must do things differently. So I went to ask the expert, the real experts, the ones who work with pliers in their hands. I got a job as an electrician on the salmon platform located in the sea, about 1,000 kilometers from here in southern Chile, where I met wonderful people who taught me about the materials and techniques to perform electrical installation over the water. And in August of 2019, I won a seed fund of about $4,000, and with my savings, I built a concept prototype in February of 2020 that you can see floating here, which allowed me to test several things. For example, on Salmon Farm platform, we have a couple of 12-hour earthquakes every month caused by storm at sea. This leads to building in such a way that everything is easy and quick to repair, and the same principle has been applied here. The whole structure is built with polyethylene irrigation hose widely used in the salmon industry to flow food to the fish, and in this particular are recovered from agricultural installations, so are available almost everywhere. Everything is tied together with cheap rope, so no fancy parts are needed, and a coat of anti-rust paint prevents them from burning to sunlight. Also, the floats are built with recycled polyethylene barrels, so as not to commit the nonsense of covering the fields with newly produced plastic. And since water currents are almost non-existent in small reservoirs, barrels filled with water serve as ballast so the wind does not lift the raft, and others filled with sand also serve as deadweights. I know it looks more than a bit rustic, but it's part of making it as cheap as possible. And so far, due to a forced trial due to the pandemic, you can see in these coordinates that it has been successfully resisting weather conditions such as windstorms and heavy rain for more than 2 years, as well as its successful behavior in the face of significant change in water level without losing its orientation, and successfully using the muddy water to clean the panels. Here you see them washed 3 days ago and looks good. And if you compare them with the current status of many solar plants, you could understand that it's better having them generating as much as they can at the beginning of their life cycle than being afraid of some scratch that will be affecting at the end of their 20-year life. In addition, this conceptual prototype allowed me to test the following tilting system that, as far as I know, is my invention, thinking about the simplest way to take advantage of the long summer days that happen in places like southern Chile or far north as Canada, UK or Germany, among others. As you can see here, my intention were that through an electronic controller that drives the remote control of a simple electric motor for vehicular gates like this one, I can remotely change the tilt of the panels. Where through only an intelligent geometry, I can arrange the panel in 3 positions during the day, improving the performance of this, and hopefully, since I have 3 planes of orientation, I also could help to avoid the hail damage. As in all conceptual prototype, not everything went well, and unfortunately, due to the deformities of the raft with these tensions, as well as the regular quality of the pulleys, the motor that's supposed to move 800 kg gate is not capable of tilting the 4 structure at once, even when I can move them with my hands. But this is enough to corroborate in real life that the generation curve my system improved by more than 1/6 the daily generation of a summer day. All this with a simple system moved only with pulley, ropes, and this cheap structure made with irrigation hose, which are lightweight and could be easily to stack for their transport. Actually, it had a problem moving just the first one, but fortunately it could be solved with just rope, a pulley, and a drum full with water in a dynamic scheme that lowered its center of gravity. I hope you find it as cool as I do. See, the movie made me feel like Victor Frankenstein. But keep in mind, this was made by an engineer with experience also as an electrician even at the sea. This project was intended to be as simple as possible, but have much more engineering involved than what you would imagine. As example, it have additional protection than the required by technical norms within that box over there. And even has some magic underwater that you wouldn't see, which makes it a safe installation that already fulfill all the requirements to be injecting electricity to the power grid. There is no way I could risk myself into the water if it wasn't the case, so please don't try it yourself at home. Electricity and water aren't a game since you could get shocked, fall unconscious, and get drowned. Better call an expert. Now, from the raft I made for placing the dead weights, I'm going to tell you a few things I have learned. Since farmers irrigate their farm only in summer, when the sun grows almost perpendicular in the sky, actually the preferred situation for taking full advantage of the solar generation during months with their high electricity consumption is to have fixed panels with almost no inclination, which increase the capacity factor on summer months. So my plan is both achieving the next project a simple raft with fixed panels with good enough quality to be sold, as also test inland the tracking system, ideal for Chile and South, which could be located in places where even traditional photovoltaics can't, like rocky plains, since are self-supported and just need a few anchor bolts for knotting ropes and pulleys. Being true that I already have my business running, where I am to learn the skill of being a businessman, this project is already beyond the scope of what I can achieve alone. It is still too underdeveloped to go to banks or local investors, so I made this video to ask for your help. But this time I need much more than when I started. It has been too much time with this project as an expensive hobby, and it needs to start to be a business soon. I require to hire people to be trained, since it's not easy to find electricians with fisherman skills. And with this team, I hope, within the first three projects, the break-even point where floating photovoltaic becomes cheaper than installing them on land, as is happening in year 2013 when photovoltaics projects got cheaper than coal-fired power plants and they spread as something inevitable. Due photovoltaics economics of scale, achieving it will be huge. Just imagine not just fight the certification, but instead making deserts go green by making it possible to make dams in places where rivers evaporate before arriving to the sea, as it happens 1,000 kilometers at the north from here in the world's most dry desert, also located in Chile. Many photovoltaic plants are currently installed there, but sinking those tubes land becoming productive to agriculture. With water available, you could even make more than one harvest a year with that sunlight levels. It's a business everyone would like to exploit. Unfortunately, traditional platforms for asking support aren't available here, so I ask you to everyone could help. All many I see everywhere worried about climate change wanting a way to be part of the fight against it. I hope you could trust me and visit www.synchronize.com and make a donation. Every teeny piece of help will be appreciated. And if you are in a condition to give monetary support, but you get engaged in my evil plan of cover the world with photovoltaics, please share the video, or even better, help me to improve the translation so I can achieve more people to ask for help. So remember to synchronize. It's renewables time. Being true that this project was built with these hands, I would like to thank now to everyone who have helped to make this possible. To Gonzalo and Corolla for letting me use their reservoir to make my project. To Luis and all the staff from Macaya and WAC for all their support and good vibes during I built it. Same from all the people I met in El Huigue, to my friends Ignacio Cristian from IER Electric and all the friends I made there, from which I learned how to make electric installation at the sea and allowed me to have a partial job to keep running my entrepreneurship. For all the people I met on the salmon industry, which were their clients, who selflessly taught me about nuts, you can bet I were paying attention. to Hernan and all the staff from Cercotex Business Development Center in San Fernando City who helped me to win the Cercotex Seed Fund, and the people from Cercotex Fund to allow me to make this project true, and especially to my family and friends to have been wondering what the hell I were doing on the last summers. It were impossible to achieve this without your support, good vibes, and patience.